My wife and I are learning sign language. And one of the things that happens as part of that is we're given a list of words every week that we're meant to practice. And I got tired of just reading through the list myself, so obviously I built something it's flashcards, it's not Anki. But it just pulls words that I haven't seen recently out of a database and dumps it into my screen, and so I can practice and mark that I've seen them, and then it does that. That's boring though. That's not what I'm going to talk about. Because obviously once I had this, I now had a database, and I had to put words into the database, and that was a much more interesting problem because I got tired of writing SQL queries. So I wrote a parser. It has them, by the way. Okay.
What else?
What else is it? Can I see my own screen? All right.
You Kabbalized it? I mean, I guess so.
I don't remember why I did that. Anyway, so my example files. Let's start off with my example SQL. So this is my rough kind of schema. I've got my vocab here. It's got a list number, which is the number in the vocab list that I have. So I might have word 1000, which is not a reliable primary key because multiple words sometimes have different meanings, and so sometimes a single word will have 6 different meanings, and so I can't use it as a primary key for that. And B, sometimes my tutor isn't using a database for some reason, and her numbers are sometimes all over the place. So I cannot rely on that. Page number, which is where to find it if I want to look it up again later. Description, which is the actual word, and then the number of times I've reviewed it. Then there's all sorts of them, word 1025 is on page 221. It is the word candy, and I've seen it -1 times because I haven't reviewed it yet. Anyway, so that's basically it. And this totally works, but it was so tedious, and I was bored-ish. So this is the file that now represents that same SQL file. So here is the page number, because there are multiple words on a page. And I have all sorts of features, like 1025 is the first word, it has candy. 1026 is chocolate. This plus means, and then the next one, because I don't necessarily have to use my human brain to keep track of which order I'm in. So this would be 1027, and then this is the next one, so it would be 1028, 1029, 1030, I almost said 1020, which is wrong. Next page, etc., 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 etc. Somewhere in here there's more features. So down here, this is 1052, then this is 1053. This one, what the fuck does that one do? Whatever. This one is ampersand. So this one means whatever the last one was, don't adjust my counter, because sometimes there are multiple words that have different meanings, but it's the same sign. So it corresponds to the same ID. So in this case, this would be 1053. This would be something I don't remember. This would be 1053 again, let's say. And then down here, what this one is an assertion, because whatever, I'm a programmer. So this one says increment as though it were plus, but check and make sure that it is 1054. So, because sometimes her numbering's off in the middle, or sometimes even I make a mistake. And so if I get to the end here and I say, okay, for the first word is this one, the last word should be 1054, and then make sure that all my pluses in the middle kind of make sense. That's basically it. So the code. Let's go find out what minus means. So in my source, this is basically all of it. I'm using, hopefully this will be readable at all when I get to it. I don't remember anymore. So this is Haskell. I'm using a library called Parser, which is a popular Parser Combinator library, which is to say that rather than traditional CSE, typically taught parsing, where you would have a tokenizer and you would go through and pull out all the tokens, and then you'd have a Lexer that would go through and build a tree out of all your stream of tokens, and then that would generate some sort of a thing. Parser combinators are like, fuck it. And they just have a whole bunch of things that you can cobble together and turn into something you want but also with that you get a lot less, although you get less magic, but not a lot less, and it is pretty cool. So, let's kind of talk about this. Where do we begin? So I have a counter. Oh, I import a bunch of stuff. Then I have a counter. So this is, I'm going to have a state, as you may have noticed as I was going through my input file, I was keeping track of a number as I was going through, and it was incrementing it on different lines and stuff. So the way I've chosen to represent that is with state, and that state is int. We'll get to that in a second. And then I have an entry. So this is a particular thing that ends up in my SQL. It has a list number, it has a description. Yes, that's all that it has for some reason. Oh yeah, it is. So this is the part where the Parser Combinator comes in. So here I've got word line. This is a particular line of my file. So I'm constructing an entry. We're going to get a little bit Haskell-y here, but it's cool. So I'm constructing an entry, and what I'm saying is that my list number here is any one of these number options. So that's going to get pulled out, and it's going to be passed in as a constructor to my entry, saying when I'm done parsing number options, pass it in as the first argument entry, because I'm using this $sign over here. And then I'm going to say there's some number of spaces that come after it. Spaces is something that's provided by the library. It's just one or more spaces. And I'm using this fun little asterisk-y thing to say there are a number of spaces. They're not relevant for constructing the entry. Just ignore them. Then I say that there is a character that is the paren, because I have those after my list numbers. I'm using my asterisk thing again to say also there's a character. If there isn't a character, it's a parse error, but don't tell me about the character. I don't actually care. It's not part of my constructor. But make sure it's there. It's really important, but I don't care. Then there's some number of spaces again, ignoring them. And then at the end, this line wraps, by the way. I have any characters until I reach the end of the line. So that's what this part is doing here. And then there's some number of spaces at the end of the line. I don't care about those either. And this any characters until the end of the line. Many till is one of those combinators that Parser Combinators are written about. So it says, yeah, just like run this any character parser as many times as you can until end of line parses successfully. End of line parses when it's at the end of the line. So it basically says if I'm at the end of the line, then wrap up everything that I've done and put them in an array for me. Otherwise, keep consuming any character. And then again, there's spaces in here. So, what are some of those things? Number options here. This is where Parser Combinators get magic again. Number options is defined down here. It is either a number, or it's a plus, or it's missing, or it's the same, or it's an assert. So that's pretty cool. What do I do with that? So I say number. This one's pretty normal. I say there is some string, which is many digits. Many one in this case is one or more. So there's one or more digits, and I'm going to put that in this variable called string. I'm going to use read to turn my string into an integer, and I'm going to use put. Puts the integer into my state, which I've got up here as my counter. The fact that there is a state at all is magic. It comes in later. Don't worry about that. Trust me, it's there. So this put says I read in many digits. I interpret them as an int, which I then jam into my state because this is the number I'm currently on. And then I return my string, which is my actual list of digits that I want to be the parsed part of the number, which then ends up getting filled in up here as the first argument to my entry constructor. But numbers can be other things. They can be a plus, in which case what I'm saying is I've got a plus character. I'm using this asterisk going the other direction to say if there's a plus character, but I actually don't care about the plus character. That's not what's important. Instead what I do care about is I'm going to modify what's in my state. So I have an integer in my state. Modify takes a function that modifies that. So in this case, 1 plus, you might not know it if you weren't in Haskell, but 1 plus is a function that adds 1 to something, or it can be.
Don't you find, well...
Were you going to say suck?
No, I'm curious why you write 1 plus instead of plus 1.
Because +1 looks like a positive integer, and I hate that that's allowed. So I write 1 plus, because it's obvious that I'm not talking about the number that is 1. So anyway, so I'm going into my state here. I'm saying there will be a character, or a plus, and if there's a plus, then go into my state and add 1, because I am now moving forward by 1 number. And then after I've done that, but I don't care about the result of that. This comes back with something. I don't actually care about what it is. What I actually care about is this part here, where I get the number that's in my state, and I use show to turn it into a string. Because what this parser is actually supposed to spit out is the string that is the number at this point. So what I'm doing is I'm saying there will be a plus, I don't care, then add 1 to what's in my state, but I don't care about the result of that either. Then get what's in my state as a string, return that as my number. And then, again, that ends up as the first entry in my thing up here.
Does modify not return the modified value?
I don't remember what it does. It might.
Because then you could just show modify.
I could. I think there's a reason why I'm not doing that, but I don't remember what it is. We'll see. Maybe there isn't. What else have I got? Missing. So, look, here's my char minus. What do I do with that? Oh, right. Okay, so I remember what minus does now. Sometimes there are words in her list. So she gives a list of words, and then she also gives like a review list of words at the end. And the list of words shows me the signs for what I'm supposed to be doing, and the review list at the end has the line numbers on it. Sometimes, though, because she's not using a database, she'll forget words that used to be over here, but now they're not over here. So they'll come between 2 signs if I'm talking about pages, but in terms of my actual list, there is no number for them. Because this one's 1021 and this one's 1022, and it should have been in between. So what I did with minus is I say, if there's a minus, then I want to use my gets function again to pull my number out of my state. And what I do is I represent it as a string, and then I just kind of tack plus 5 or 0.5 on the end. So it becomes 221.5. But I do not modify it for some reason. I guess I didn't want to do that. I guess that makes sense because it's the same number as the last one. Whatever. Anyway.
If there's more than one of them, they'll all be 221.5, but
Right.
what the fuck are you going to do with that?
Yeah, exactly. So same, this is the one here. So this is my character that's an ampersand. I just print out as a string my inner state, and I return it as my number. And my assert is a little do block here. It says first there's going to be something that's an equal. Then I'm going to apply my +1. I'm going to project what my +1 would be. That's my target. So I'm going to get what 1 plus my current state is. Then I'm going to get my actual string, which is many digits all as a string. Then I use when to say if my string for my target is not the same as the string for my string, then I'm going to fail. And I'm going to say assertion failed, expected target got string, basically. If I get to this line down here, then obviously I didn't fail a second ago. So that's fine. So now I just say, great, I'm just going to put my target number. My target number was what I expected it to be, so I'm going to store it in my state, and I'm going to return the string that I was given. So this works as a +1, but with this check that fails in the middle. And that's how I parse each line. And then, like I said, the magic of the combinators is up here. I say that a number is any one of these things, and whichever parse fails, it tries the other one. Because of magic. And then down here, I've got a page.
Well, it doesn't actually do that, because you're using normal parsec, right?
Yeah.
And you're not using try,
Um,
which means it's not doing backtracking, it's doing immediate failure. Right?
No, it doesn't do backtracking, but since they only differ by 1 character, it works the same.
Yeah.
Yeah.
But it actually just checks the very first character
Yes.
for each one.
Which is why I used the very first character as the differentiator. Yes. If anyone cares, they can ask me about that later. Page. So a page basically is it has a string at the front, which is the page number that I'm on. It has maybe a string, I don't remember. Oh, because I can set the default views on any given page. So some pages I have reviewed before, so I want all of the ones to start at 3 views, but all the other ones I want to start at -1 or whatever. So here what I do is I say, I've got a page again, this is what I'm constructing. There will be many digits, which is this first value to the page, this is what I'm parsing. Then there will be some number of spaces, but I don't care about those. And then I have maybe the views. I may or may not, and it'll take care of, the parser library will take care of, if this doesn't parse, then make this a nothing, because there was nothing there, and if it does parse, then views in this case says that first there will be a paren, then there will be a bunch of digits, and then there will be a closed paren, and then there will be a bunch of spaces. So if that's present, then it will provide it, otherwise it will skip over it, and it'll just automatically construct for me a page with a string and then nothing else. And my parser is here. I'm saying I have an indent-aware parser, which ended up being a library that was less useful than I wanted it to be, but it still basically worked. It has a string, or it takes in strings. It doesn't actually result in a value, because I don't actually care. And it, wait, that's not that one. Whatever. And it has an internal state, which is a counter, which is the integer that I'm counting along. And what I get out the back is a list of things that have a page and a particular line entry on it. And the way I do that is I go through, I say there are going to be many blocks that have a combiner, which basically just takes all of the entries I get and tacks the page on the front. So every entry is going to have the page that they're part of the larger block of, and then the individual line. And what it's going to do is it's going to parse the page number as the beginning of the block, and that word line that I started with as every item in the block. And then, like I said, it's just going to tack them together so that every entry gets paired up with the page it was on. I'm going to jam those all together, and then at the end, I'm going to stick those all into one flat list, so I just have a list of all of the words on their pages.
So with block is the thing you're getting from indent parser.
Yes, with block is what I'm getting from indent parser. Which is what with block's value is it interprets a block as a thing that has consistent indentation, so I don't have to, because my parser is indentation aware. And so basically I can tell if this is how you parse the first line of the block, this is how you parse the indented part of the block. You go figure out where the block begins and ends.
That's pretty cool.
Which is nice of it. Still, it has some fucking huge quirks, but I figured out how to work it, so it's fine.
What are the quirks? What are the quirks?
It expects me to consume the indentation, and then it just expects but only some of the indentation.
So it makes sure they're all the same, but it still feeds the spaces on to you.
Yeah, and if I don't consume it, then it thinks everything's its own block.
Right, of course.
But including, like, it expects me to include over the end of the line and up to the next line.
Yeah.
But then just make sure it's cool though.
Yeah, so it's just feeding you all the white space for no reason.
Yeah, and if I consume too much of it, it straight up doesn't work.
Yeah.
Yeah. So anyway, and so this is my output here. So I passed in my list of items, which there's no type signature for, but I can bet that it's going to be like this. And what I'm saying is, I just build up a string. I say insert into vocab, list number, page number, description, number views, with values, which are my values, and then I end in a semicolon. My values, what I'm going to say is for each item, I'm going to run tuple on it, which turns it into a SQLized thing. And I'm running intercalate, which just takes all of my items and puts a comma between them. It's join on most languages. And tuple. Yeah. Obviously, it's called intercalate. And tuple basically is just going to take in my page on the left and my entry on the right. And it just does some string garbage, like put a paren and then the number of my list number, which comes out of my entry.
Why did you call it tuple when it clearly makes a string?
Well, because the string is a SQL tuple. Anyway, I don't know. So then I put a comma, whatever. I take the page number out of the page on the left. I take the description out of the entry on the right. Here I might have a number of views on the left, but I'm not sure because it's a maybe. So what I'm saying is take the views, put them in verbatim if it's a string, otherwise put in a -1 as a default case. Just kind of jam that all together. Down here I separate with commas again, and then I just jam it up in my SQLite here. That's basically it.
Are you using SQLite?
Yeah.
But you're using double quotes? Does that even work? I mean, it must work.
Double quotes. Yeah, I don't know why, but it does.
Okay.
And I don't know why I'm using it. And so then the last part before I get to the very end, since I've covered
You have
every other
eval
thing-
state undefined? What?
Right. Well, so I don't have an initial state for the numbers because I don't know which number I'm starting on until I have the first line. So by using undefined, if I try to put in anything except a number on my first line, it will look in my state, it'll get undefined, and it'll crash, which is great.
I guess that's, yeah.
Because otherwise, if it was a 0 and I started my file with ampersand, it would be like, great, I guess this is also 0. And it would just get weird. So instead I put it undefined, and it crashes for me when I use a number before I've defined one. Perfect. So eval state, this is just all the machinery that lets me do all the magic I did up there. So specifically, eval state says go do this stateful thing, but then tear it apart again so that I can actually use it because Haskell has state, but it's explicit. So this is the explicit part. My initial state is undefined, which is what I was just talking about before. There is a number. There is no number. My indent parser here, so this is the one where I actually take my parser, which is this guy up here that like runs many times and consumes all the blocks. So I say go run the parser, come back when you're done. I use standard in because I read from standard in, so when it's reporting errors, it'll tell me error on line 6 of standard in.
Oh, that's the file name, okay.
Yeah, it's the file name. I don't remember what the hell this is. I guess my parser has like an initial value or something. I don't know why that's there, but either way I passed it nothing because apparently I didn't need it. Get contents reads standard in into a string so that I can pass it into run parser.
A lazy string.
A lazy string, but in this case it's fine. So I read all the contents in, I pass it to my parser, and what I get at the back is my parse result, which is my thing that looks like a list of pages and entries. And then I just have a little case statement here that says, if this thing was a write, then that means that my parse succeeded, and what I have is a list of items that are pages and entries. So in that case, I spit out to standard out the result of my output function on items, which is this guy over here that builds the actual SQL. And if I got a left, then my parse failed, and there's some sort of error string responsible for that. So in that case, I'm going to print the standard error, whatever error I got, and then I'm going to return exit failure to say, holy shit, you fucked up. So that's literally every line of my parser. But there's only like 48 of them? 54. So that's not too bad. And it probably even runs.
That would be cool.
Let's see. How do I run it? Cabal run, I think I did, and then example file. There it is. Parse. Then I go into example. Oh shit. I go into example. No. Example file, and I say this. I don't know. This is going to be equal to 1031, which it won't be. Then it's going to say, oh shit. There's an unexpected bracket. I was expecting 1032, but I got 1031. Yep, that's basically the whole thing. That's what it does. Or if I took this and I, here, let's make it work. 1032, and then I took this and made it a star or something. Then you tell me, okay, on line 10, column 7, I was expecting a digit or white space or a paren, but you gave me a stupid asterisk. Because that's the kind of magic thing that the Parser Combinator can do, because it has enough information to know what there should be and why the parse failed when it got there, sometimes. Woo! Questions? But that. Oops. Yeah.
So I was just confused about why you need to consume spaces after the end of the line. Was that to get the indent parser stuff to work?
Yeah, that's exactly right. So yeah, my
Because he's
indent
got
parser-
spaces at the beginning of the next line that he needs to consume. Because the indent parser is handing you the whole block,
Yeah.
but with all the white space intact.
Yeah, which is not what I was expecting it to do. What I was expecting it to do
Is unindent
is
and
like
then pass it to you?
read ahead to find the end of the block, figure out the indentation and consume it for me, and then pass me in the unindented block many times. But that's not what it does do, probably for good reason even. So instead, I have to consume all the spaces so that it can figure out what the hell I'm trying to do right now. I guess it's so that I can have multiple lines if I wanted to, and they'd be consumed as one item instead of two. So it's like, look, you consume until you're done, and then you come back to me, and I'll tell you if you.
Well, maybe you want to know the white space for reasons.
Maybe, I don't know.
Like some templating languages, the white space that you indent with is significant, but still outputs.
Yeah. So anyway, so I have to consume the spaces so that my indent parser knows what I'm doing, I guess. Because if it sees extra space, it'll assume I did something weird, and it'll tell me that my block failed to parse because I had all this random crap
Yeah, if you have
that
any
that I didn't
leftovers.
consume.
Leftovers
And it doesn't know
is bad.
what to do with it, so it's just angry.
So if you put 5 spaces in your file, it'll fail or not?
Right?
If you had like 5 spaces instead of 4, doesn't that fail?
No, that'll be fine. Yeah. Here. Well,
But it depends. If you had 5 spaces on only one line and 4 on all the others, it might fail.
yeah, let's find out. I think this will be okay, but I don't. Maybe it'll fail.
Huh?
Okay, so what it did there is it successfully parsed this block, realized that this was from a different block, and then was like, I parsed one of them, and then it gives me that answer. Because technically all I'm asking it to do is to parse one or more. And it was like, I parsed one, successful parse. I should probably take that out. Like, assume that there will be an end of file at the end of the
Yeah.
thing. But
Just putting end of file in should
Yeah.
do
uh, anyway.
that. Expected end of file found
Found
space.
Other random garbage. Yeah. Other questions?
What other ways you could done this without this approach? I mean,
Oh, tons. Well, I mean, by this approach, I assume you mean Parser Combinating
Yep.
and Haskell. In which case, the answer is I could use a more traditional two-phase tokenizer and abstract syntax tree lexer. In which case, basically what I would have had to have done, if I go to my example file,
It would have been way harder to do the indentation
yeah,
first.
I would have to have treated the indentation as a token, I guess, and then I would have to go through, and it would be a context-sensitive parse because I need similar indentation to like be one thing and something else to be something else, I assume. So already, this computer science is mad at me. Then I would have to essentially parse this line as like the page number token, and then I would parse this as a thing, and then in my lexer I would say that I would have a page number followed by a block of multiple line numbers, and it would all kind of like.
You'd probably
shoot
actually want
together.
to. You'd probably to get it really good. You'd probably want to do 3-phase. You'd do you'd do an initial phase where you desugar
desugar
you
into
desugar the
curly
syntax as
braces.
curly braces or something.
Yeah, that's what
and,
Haskell does.
And then you'd lex that into tokens, and then you could do a traditional context-free grammar where
Yeah.
you just do blocks of curly braces that are nested or something. That's what you could. That's probably the easiest way to build something like
So what
this.
Steven's saying is what Haskell does, because Haskell has a indentation awareness. So for example, these things here are part of this function because they are indented, and this thing down here is part of its own function because it's outdented. But the very first thing that the Haskell compiler does is it goes through and says, aha, block, and it jams some curly braces in here.
It also puts semicolons on the end of all the lines.
Right, and then it puts semicolons on the ends of the lines that need them, and it goes through all of this stuff, and then at the end of all that, actually this one is another curly brace, because it's indented again, and then at the end of all that, it's like, okay, now that garbage is out of the way, it can go through and do an actual parse where it ignores all of the white space, but it was expecting all of these semicolons and curly braces. And that's how it gets away with having a grammar that's totally reasonable, but without having to do any of the indenting stuff. There's an initial pass that just gets rid of all of it and puts in C again, and then the C parser that actually does the thing. I mean, not literally C, but C-like. More C-like than Haskell likes to pretend it is.
Yeah. You missed
So
one.
yeah, I guess I could do that. And it would be fine, but I don't know. I prefer this one mostly because it's less rigorous, and I'm building this because I want to just kind of slap something together. And parser combinators are delightful for slapping something together. You just kind of jam it in, and you put your logic and your parsing all into one ugly blob, and it all just comes out its data. Super great.
Basically, the biggest problem with parser combinators is that because they're completely Turing complete, you can make infinite loops in your parser.
Yeah, absolutely.
But as long as you don't do that, they're pretty good for being quick to build.
Yeah, because if this was Lex and I was doing not particularly shady things, the magic is that the Lex compiler that looks over my grammar file can say, dumbass, that's going to be an infinite loop. Like I can just declaratively see that what you've written here is bad, and it's not going to work. Or it can be like, hey, did you know that this is crazy ambiguous? The parser combinator does not care. It just applies whatever it can, as it can. It's greedy when it can be. And if you are ambiguous, but you put this thing further on the left than that thing, then that's the path we're going down from now on. So you just try not to do that, unless that's what you wanted. In which case, do whatever. Great. Other questions?